Hey, physics fans! Welcome back. Let's just take a look at this little simulation here for the Energy Skate Park. We have the skater going back on this curved one, and we have some graphs going on here. Let's slow down the simulation speed and just take a look at the kinetic stops. When he's at the very top, kinetic becomes 0. And it becomes 0 over here when he stops. The potential, when he's right at the bottom, is at its lowest, and its kinetic is at its highest. This goes right down to 0. And potential goes all the way up to here where the total energy is. The total energy, as you see, as you go back and forth when you add the kinetic and potential, is the total, and the total is staying the same. Why isn't the potential going all the way down to 0? The question is, though, speed it up and slow it down as it comes back down, and pause it at the bottom. Oops, I missed. Okay, and pause it at the bottom. What is his potential energy? Well, don't you all have the correct answer? It's not a number. It's with respect to what? Because you measure the height with respect to something. So let's turn on this potential energy reference. There's the ground. That's where potential energy is 0. So we're measuring it with respect to the ground. Generally, that's what we do. But we don't have to have the potential energy there. We could set the potential energy to be 0 right at the bottom. So when we play it now, and update this, the potential energy is now 0. But if you notice, the total energy went down too, because the potential energy plus the kinetic is what the total is. And if now the potential goes to 0, then it's just the kinetic. The kinetic didn't change when I moved that. So as we go back and forth, we see that the potential will go all the way up to the total. And now the kinetic will go there because we put the 0 point right there. And I turn on the grid, and we notice that he goes up to about here. What if I put the potential to be 0 there? Move it up a little bit more. Why? Because it was just a little total. If I do this, the total energy is now 0. Potential is going down because it's with respect to here. So you can have a negative potential energy. Can you have a negative kinetic energy? No. Okay. See what's happening? That's good. Now, I'm going to apply a rocket on him for a few seconds. I increase this kinetic energy quite a bit. Is he going to leave this half pipe and fly out? It's hard to tell. What happens if I move this up to here and go play pause? Will he be leaving that area? Can we tell now by the graphs? Will he be leaving? Is the potential energy? What do you think? Do you think he'll be leaving? We're slowing down the simulation now. He's moving pretty fast. Well, when the potential energy is 0, meaning he's at this point, what will its kinetic energy be? It will be there. That means he'll still be moving. So yes, if I play, he's flying out. Oh no. What's going to happen when he hits the ground? Thermal's going to go up. It's going to squish them. Ouch. Bam. Kinetic's gone. Potential is negative. Thermal's up there. Cool, eh? I think so. Let's clear the heat. Put the skateboarder back up here. And so we've learned a little bit, right? Is he going to leave the half pipe? Look at the graph. When he reaches there, will he have a kinetic energy? No, in fact, he won't reach there. When kinetic energy is 0, the potential is going to be this amount, which is still negative. So can the total energy of the system be 0? Yes. Can the total energy of the system be negative? Yes. Interesting. Okay. I kind of like it. It's good. Let's speed that up now and just let him do this half pipe stuff. Then we turn on subtract friction. Every time he's going fast, which is the fastest is down here, is the faster transfer of thermal. So when he's in the lowest point here is when he transfers the fastest. Let's take him up here. You see, he goes fastest when he's down here. Goes fastest, I mean transfers this energy to thermal. And if I put the potential to be at the very bottom, all the energy's gone to heat. Okay, one more little bit of fun and then we'll cancel the video. Boom, boom. It's traveling really fast now. What happens if I turn off gravity? This is pretty hard to do in the lab. Boom, put him into space. What's it going to look like? Well, he has a high kinetic energy. No slowing him down. Gravity's not slowing him down. Oh no. Okay, Mr. Girl's having too much fun. Every time he does this little jump here, boom, thermal jumps a little bit more. But hey, we have rockets when we're in space. Turn off the friction, and he'll go forever. Anyways, thanks for watching and having fun. If you need to go here, just PHET, P-H-E-T, search for Energy Skate Park. PHET Energy Skate Park. The Java version here is what we need here, because this one is the fun one where we can move the 0 point around. In the new one, you can't do this. And I think that's a good learn. Anyhow, thanks. Boy, that was 9 minutes longer than I wanted it to be. Well, enjoy. Here comes the tunes.